Hey guys, welcome back to Toy Garage. In this episode, let me show you my project of the homemade motor-driven display stand. First of all, I need to tell homemade this tool is not cost effective at all, and I did it just for fun. It is still in progress, and there are a number of problems that need to be improved. Let's talk about the first version. It is the first version. It was a failure because it is noisy and it rotates too fast. Anyway, let's take a look to it. In the very beginning of this project, I want to check out if 3D print is good for making gears, and in the same time, I need a rotating platform for recording purpose, and therefore I start this project. This big motor, is coming from an AEG airsoft rifle. This kind of motor is tuned to be high torque, and a typical airsoft AEG rifle is powered by a battery of minimum voltage of 7.4 volt. I will power it up using this 8.4 volt battery. And I made a motor mount to fix it on the base, this base, and connect to the motor is a big pinion worm gear. I use worm gear because it is able to reduce rotational speed in large ratio. Next to it is the reduction gear and the final spur gear. Both are supported by metal ball bearing. Take a closer look to the two gears. There are many flashes over the teeth, and I have took a long time and tried my best to clean them. It was my fault. I used low quality profile to clean them out in order to save time. Let me power it up. Okay, it is noisy and very noisy. Even though when I move the motor mount in this direction to let it disengage from the two big gears, the noise level coming from the motor itself is still very high. In addition, the speed of this spur gear is too fast for display stand purpose. Let me give a short conclusion for it. First, I choose the wrong motor. It is too powerful, and I tried to run it with power transformer with lower voltage, but it does not move. And second, the print quality of the gears are bad, partially because I choose the wrong printing profile. But even with high quality printing profile, I wonder flashes and the elephant foot effect still exist to make the gear run unsmooth. For elephant foot effect, it means the first few bottom layers were printed bigger than the designed value. Take a look to this here, and take a look to this printing here. At the bottom of the motor mount here, you will find they are a little bigger than the upper area. This is the elephant foot effect. Maybe 3D print is not very good for this scale of gear tooth. Bigger tooth should be able to improve the issue. And thirdly, If I keep this motor, I need at least 2 more reduction gears to further decrease the rotational speed, which will make it more noisy. I think this setting is not good. I need to think it over again. Now let's check the second version. The left one is the skeleton prototype that I made with minimal amount of material for a rapid testing. It was a success, and therefore I make a strong version, the right one. Let me talk the stronger version directly. This version consists of 2 parts, the tabletop and the base. Let's talk about the base first. The key features of this design is to make use of a radio control steering servo in here. It is attached with a 3D pinion here, which will drive a big spur gear directly under the tabletop. There are 3 metal ball bearings installed on the top edge of the base, which will support and let the tabletop rotate smooth. For the servo, it is a cheap plastic gear steering servo for radio control trucks. In the radio control world, it is entry grade, or even I say it is a rubbish. I have done 2 internal modifications with this servo. First, there is a stopper in the output gear to limit the rotation angle. I have cut it away. And second, I have removed the circuit board. Power lines are directly connected to the motor. Talking about the power lines, it is a wire from a computer mouse, and therefore the servo will be powered by a USB power source. Let me show you how it runs. And I feel it is still noisy. And now let's take a look to the tabletop. This is the wheel for holding 3D pin material, and the 2 halves are glued, and therefore I can cut it into 2 pieces easily. And I use one of them as the tabletop. I have made a big spur gear to attach it under the tabletop, and also make a lid with my channel name here to cover the hole in the center. To install it to the base, it is simple. Just put it over the base. Let's power it up. It is still noisy. The noise level doesn't change whatever I use the tabletop or not, and therefore it is not due to the 3D pin gears. The noise coming from the servo. The voltage provided by a USB power source is 5 volts. Maybe I should try a lower voltage. It will definitely make it run slower, and hope it can also reduce the noise level. The second problem I found is the 3D print gears are not smooth. You can find that the gunner figure shake at some moments. I will do further filing to smooth them out. The third issue, a minor one, I feel that the rotational speed is still on the high side. Maybe I need to make a smaller pinion gear or try something else. I don't know. Now let me try some heavier stuff. It is one of my RC monster trucks. It weighed around 3 kilograms. Sorry for the odd view. The truck is too big for my current recording setting. Anyway, let's power it up. Not bad. I hear the tone of the noise coming from the servo is changing high. That means the servo is on high loading. But also, I didn't feel the rotational speed decrease dramatically. I do feel the servo is powerful enough. The project is good to continue. That is the end of this video. If you like this video, please subscribe, share it, and hit the like button. Really appreciate your support. Stay tuned. Bye bye.